Those are the apps that business users are building themselves. And we're going to see just how far we can take it to really get where we want to be. So a quick note about myself. I lead an OWASP group dedicated to low-code, no-code. So that's like the top 10 for low-code, no-code apps. If you're interested, check it out. We have over 200 people that are kind of part of this group already. I lead a company called Zenity, which is focused on this area. We've been around for something like 2 years, and I've actually been focused on security for low code for about 4 years now. Started off at Microsoft. I was part of the team there that created a bunch of new products that are around like Defender for X, so Defender for APIs, Defenders for IoT, and others. And I also write in dark reading. If you're interested in this topic, there's a bunch more that I'm going to share, more than today. So reach out or shoot me an email or something. Okay, a quick disclaimer. Of course, even though this talk is given from an attacker's perspective, the idea, the kind of low code is awesome. This thing is really, and we're going to say it in a moment, low code is really putting power in the hands of business users, which are, of course, the people that are kind of the best to move the business forward. And we're going to see just how kind of what those people are able to actually create. But it's important to do it in a secure way, and that's why we're giving this talk. So here's what we're going to do. This is a quick outline here. We're going to start by making sure that we're all on the same page on what low code, no code is, just so we understand it better. After that, we'll dive deep into attacks that were observed in the wild. We'll start off with living off the land attacks. You'll find that low-code apps, they have compute, they run on somebody else's cloud. They're really difficult to monitor, which makes them the perfect thing for living off the land attacks. We'll also see persistency mechanism, and we're going to follow an APT group that actually used Power Automate specifically as a persistency mechanism. And then we're going to see these predictable misconfigurations. Just think like OpenS3 buckets and how long we've tried to solve that problem. So we're going to see this pop up again here. And of course, we'll drop it off with how you can protect your organization when you go home, but also a few tools that you can play around with to just kind of get a feeling of it. So let's start with low code. The number one slide that's kind of throughout this presentation, the most important thing you're going to see today is the next slide. So here it is. This is a chart that's representing a single Fortune 500 organization and the number of applications that were built by their business users using low-code, no-code. Of course, this is anonymized, and we are seeing this across multiple organizations, and the numbers could vary. But when you talk about business users building applications, or in other words, people are calling this citizen development, this is taking off in a way that's really unprecedented to what we know from kind of professional application development. I mean, how many applications are built in your org every year? 100, 1,000 if you're huge. Not you won't find 5,000 or 10,000 applications that were built by professional developers. That means that everything that relies on manual operations won't work. Security reviews won't work. Threat modeling won't work. Just kind of vulnerability management. If you need to take a look at all of these different applications, these won't work. We need a new approach here. And that's why this is important. You're also seeing that this chart goes up very rapidly. And this is kind of just with the proliferation of these tools across the enterprise, where more and more business users are becoming aware of it. Of course, not all of these applications are huge. Many of them are very small. You can call them micro apps, but they still have identity. They still touch data. They can still do operations, so they still pose a risk. All right. So this is essentially trying to capture why low code exists, right? And this is a perennial problem. We will never have enough IT resources to target everything that the business needs. And also, I mean, things get lost in translation, right? When somebody from the business needs something done and they need to get somebody convinced so they can actually go ahead and build it, things don't work properly. And if this sounds familiar, like this idea of enabling business users, if this sounds like not a new thing, well, it's not a new thing. It's been around since forever. If you think about Excel, for example, That's like the perfect low-code tool, right? Everybody's using Excel. I've been using Excel across my career. I've learned a lot of things, but Excel has always been there. So, and imagine, and think just how many jobs are fully focused on Excel, are empowered by Excel. What low-code is trying to do is basically bring you the next generation of Excel. And when you look at this chart, one of the things that's obvious is that the risks associated with these technologies that are enabling business users, they've also been with us since forever. So Excel had macros, and macros are, of course, a problem until today. And so this is part of a trend, and IT decentralization, giving more power to the business, to the people that actually move the business forward. So what are people building? So let's try and let's try and understand what are the types of things that these applications can be. So they can be whatever people want them to be. So a lot of them are these like if this then that automations. So you take, for example, every time you get an email, you do something. Every time a file arrives on SharePoint, you send it off to your private Google Drive. These things are kind of the number one scenario. On top of that, you'll find integrations. So one system can talk to another. You'll find business applications that are facilitating a specific workflow. So for example, at Microsoft, they built, their marketing team built an application that is used to basically coordinate product launches. So everything around product launches is built into this app built by the marketing team. You can find all products that have been built with low code, with professional development teams, and of course mobile apps. There's a lot of them. Now, one thing that you could have in the back of your mind right now that would allow you to kind of try and escape this talk unharmed is to think that this doesn't apply to you or that this doesn't apply to your organization. So I'm sorry to be the one to say this, but you don't have a choice. If you're using any of the top SaaS platforms today, the top enterprise SaaS platforms, low-code is being pushed in. You don't get a choice. Nobody asks you. If you have Salesforce, if you have ServiceNow, if you have Microsoft, they are, in order to make their platforms more useful to your business users, the capabilities, the automation, the integration, the application capabilities are being pushed into those platforms, and you get some of them with the basic license. That means that in most organizations, it's already there. I've actually never seen an organization, and we do this engagement a lot, where we go kind of partner with someone, and we look at their environment, and we try to see what's already there, and they're like, well, yeah, nobody's doing citizen development here. We're a bank or something like that. Nobody will ever let business users build their own things. Well, reality is different, and so I really encourage you to think of this as something that will happen. It's very similar kind of in nature to to the way that we had to handle a mobile or bring your own device, where we had some time we thought that it might not reach the enterprise. We will never allow bring your own device in this org. Well, today everybody's doing it, right? Because there's no other way. So it's really important for us to understand that this is already something that our business users have the capability to use. By the way, this is a good thing. It's not a bad thing. It's allowing business users to actually produce more value to your organizations. So a quick recap. Low code is available in every major organization. We just saw this. Because these platforms are the platforms that hold your business data. So imagine your Office, your Microsoft 365, your Salesforce. Then by definition, it has access to business data, and it is able to do business operations. And it also powers business processes because business users are building it to facilitate their operations. It runs as SaaS, and we all know that it makes it challenging to monitor and to control. And as most of us know, I mean, it's pretty underrated by IT and security teams. The things that business users are building, we're used to think about them as as toys, as something that they use for their own personal use. That's really not the reality today, and we'll see. And one of the kind of largest things that happened in the last couple of months, of course, with the introduction of things like ChatGPT into low code, is that business apps have become even easier to build. So today, instead of kind of writing a prompt that will give you an answer, you can write a prompt that will build an app. This is actually available in Microsoft 365 today. And so the number of apps, of course, only gets bigger. All right. So we've gone through the kind of intro section. One last thing I want all of us to make sure that we get correctly. Is this better?
If you get a little closer.
All right. I'm gonna lean in. Okay, so we went through the intro, but one thing that I want us to make sure is that we understand, we have an intuitive understanding of what these applications are, and I also want to make sure that you're convinced that everybody can build these applications. So let me show you an example, and hopefully this will work. All right, so yeah, you probably, maybe you'll see something in a moment. But while this is working, let me share what I'm actually building here. So we're using Slack in my company, and there's this annoying thing about Slack where if you mention someone on a public channel, then if somebody mentions you, then they expect you to answer pretty quickly, which is, this is kind of annoying. So, but I've noticed that if you have this small icon next to your name that says that you're on a call, then they're fine. They won't nudge you. So here's the automation. Every time I get mentioned on Slack, I'm going to change my status as if I'm on a call, so people won't bother me. And 5 minutes later, I'm going to change the status back to free, so nobody will be suspicious. And so this is a small automation that I'm building, and while I'm building it, you can see that I'm dragging and dropping. I had to choose a specific account on Slack that I'm going to use. This demo is actually showing you Zapier, so it's able to go to the Slack API. Think about kind of the complexities of this application. It needs to subscribe to a webhook. It needs to reach out to the API afterwards. That 5-minute wait period means that there's some sort of state. It needs to wait, right? And you can see that while I'm building this, there's nothing sophisticated here and on the builder side. This takes me about 2 minutes to build this application. And I want you to notice a couple of things. One is that in no point in this, while building this application, do I need to provide access to Slack. So how does this work, right? How does Zapier connect to my Slack account? We'll see that in a moment. And the other thing is, think about the SDLC and compare it to what you're seeing on screen, right? There's no SDLC here, right? I'm just building something, and once I click save, it will be deployed in production. And by the way, some platforms also auto-save. So any change that you make is automatically being pushed. And if you think about this as for a critical process, then think about all of the things that you lose by not having an SDLC, right? There's no review, there's no security gates, kind of forget about shift left. Okay, so you just saw that I got kind of this little icon there. I'm publishing the Zap, that's it. It's operational, and now I'm kind of demoing that it works. So again, this was just a couple of minutes, but you understand just how powerful this application is. So the number one thing that's important to us is the identity. And actually, before I created this application, I've gone through a very small process, which is called creating a connection. So what is a connection? A connection is basically an OAuth consent flow for Slack in this case, and you can see the regular OAuth consent flow that's asking me for specific permissions. I can choose a bunch of applications. These platforms come built in with hundreds of different connectors, and once I go through the OAuth consent flow, I get this object created, which is called the connection. Okay, what's important about this connection? It has this little share button. This is weird. It's an OAuth. I went through an OAuth flow. I granted consent for Zapier to act on my behalf, and then I can share that consent. I can share that connection, that active connection with other users. How does it work? Okay, on one side we have Zapier or Power Automate or any other automation platform. This is not picking on a specific vendor. The entire industry is doing the same thing, and I'll tell you in a moment why. The other side, on the other side, you have REST APIs. By the way, this could also be your on-prem, your cloud, anything. Okay, how does it work? Well, essentially, what they're doing there is that they are taking the refresh tokens out of the OAuth consent flow, and then they are allowing you to share those refresh tokens with other users. Okay, think about what this means. This is completely breaking the permission model, completely breaking the OAuth model. Because This is a user impersonation by design. The application is impersonating the user, and you are impersonating the user when you share those connections with other users. And so by storing these refresh tokens and then reusing them, you are able to, kind of bypass anything that, I mean, again, you're impersonating the user, but also think about the productivity benefit. No more asking for permissions. You can build whatever app you'd like with your own permissions. As long as you can do it as a user, you can build an app that automates it. This is very different from your experience as a professional developer, right? As a developer, you need to ask for permission. You have an application, it has a service account or something like that. Not here. I mean, you can do it, but in many cases you don't. Now, because you've seen the chart of the kind of with so many applications, and it's so easy to create those applications, then you get a whole bunch of applications. And these are just examples from kind of templates provided by the different vendors. The important thing about this is the logos next to the names of these applications. Why are the logos important? Because that means that there's an active connection to each one of these systems. So when you have lots of different applications, behind each application, there is a trail of connections that can be shared, connections that can be overused. And so when you look at each one of these platforms, what you'll typically find is some notion of a default environment, somewhere where everybody can go into this platform, they can create applications, automations, connections, and they can share them with others. Now, this sharing thing is one click away. In some platforms, in some cases, it can be shared with the entire org by default. And when I say the entire org, I mean everybody, for example, everybody in your Azure AD tenant. So that includes guests, by the way, or contractors and vendors. So when you go into one of those platforms, again, they are basically providing you credential sharing as a service, right? Which bypasses the entire security mechanism. Think about the SOC trying to figure out what's the difference between an application using your refresh token and yourself. I mean, it's very difficult. Now, of course, once we have that, then you can see the first attack here, which is just kind of privilege escalation. This is basic. So the end result here is that when I have a single account in your org, again, this can be a guest account as well, and I go to each one of those platforms, there's a bunch of connections that are waiting for me to pick them up and use them. You'll find FTP connections, connections to people's Outlook and Teams. You'll find connections to people's cloud environment, Azure and AWS and GCP. So this is a lot. Now, other than just using those connections, other than just kind of getting those connections and being able to escalate your privileges, you can also just use those connections to actually get what you want. So for example, here's one ransomware built with no code. What you're seeing here is that I'm iterating, so I have I click a button, and then I'm iterating over a SharePoint site. For each file in that SharePoint site, I'm going to encrypt that file using a handy encrypted function provided by the platform, right? Because there are valid business use cases to encrypt files. And then I'm going to simply override the file. With the encrypted version. So ransomware, again, using no-code tools, and just, again, think about all of the protections you have in your org targeting ransomware. They won't really find this, and we'll go in and we'll talk about, and we'll see in a moment how this goes well beyond SaaS. Here's another example. This one is, I think, in almost every organization I've worked with, I've seen this example in some form or another. We've tried to block business users from, or users in general, from using their own personal accounts in a work context. I mean, we're all guilty of that as well, right? Everybody wants their calendar events in their personal Gmail. There are solutions to do that. You can use DLP, you can do something on the email server, a bunch of things you can do. But what if the business user creates an app that on one side connects to their corporate email, and on the other side with a separate connection connects to their own Gmail account, and simply copies the content. The content is being copied on the SaaS vendor's cloud. So no network security appliance will help you there. No monitoring will help you there. The only thing you can do is look at the platform itself, because it's the only one that's aware that this application even exists. Now, you're seeing here an example of email exfiltration, and again, this is very common. But we've seen this with other things as well. So syncing up a corporate drive with a personal drive. We've seen cases where people, by mistake, I mean, they build an application that other business users are starting to use. It's useful. And it uses, for example, an Excel spreadsheet as a database. But where is that Excel spreadsheet stored? Because as easily as you can plug in your corporate account, you can plug in your personal account, and that's it. And the application the database behind the application is being stored in your personal account. Here's a thing that's kind of very non-trivial. You can jump to actually to people's laptops through these platforms, because there's a component or a version of low code that's called RPA, robotic process automation, which is basically about emulating the mouse and the keyboard, the inputs by the user on the user's own machine. And it's a type of automation that's used for legacy systems that don't have a proper API. Now, again, imagine a SOC analyst trying to distinguish a bot that's doing that and a user that's doing that. This is a bot that's running on a user context. Now, these connections allow you to send a payload, or in the world of the platform, like a task, from cloud to somebody's laptop and run it on somebody's laptop. And actually, at last DEF CON, I showed how this exact capabilities by Microsoft can be used to create malware with no code and with completely trusted services and executables. This thing is packed into every Windows 11 machine, right? So if you have Windows 11, open it up, search for Power Automate, you'll find it. It's trivial for an attacker to subscribe, to attach the Power Automate instance you have on your laptop to their own malicious cloud. And from then on out, they can send payloads to your machine through trusted channels facilitated by Microsoft. So if you're looking for network IOCs, this would be Microsoft domains. If you're looking for executables, this would be Microsoft executables, right? Now again, this is not picking on Microsoft. This is a problem with this entire space where impersonating the user is kind of the mainstream. All right, so the one thing one thing we wanted to do in order to make it easier for you to check kind of your own status and also to play around with this is to give you a tool that you can work with. So this is a tool that's available right now. You can check it out on GitHub. Basically, it's very simple. It's using the Zapier unofficial API to provide you with all of the connections that are available to a specific user. So you give it access to a specific user, and it will show you all of the connections that this user can use, and who created those connections, and where are they leading. We are working on similar tools for other platforms as well. So if you're interested, start the repo. You'll get the notifications. All right. So the next thing I want to do is a bit more sophisticated. Up until now, we were focused on a scenario where these connections already exist. But what if I want to entice a user, to make a user create those connections for us? Essentially, here's the idea. I'm going to build an application that's useful inside an org. Let's say I have an account for somebody inside an org. Again, could be a guest. And then I want to get to the CEO. I'm going to create an application that the CEO would like to use. And then once the application is running, I can do whatever I want with the connections provided to me, right? And then I will, alongside doing the thing that is expected of this application to do, I'm just going to steal the account. So I'm going to continue to describe it while I do it. So again, you'll get a notion of just how easy it is. But essentially, this thing is not new, right? An application, when a user logs into an application, the application can do whatever it wants with the permissions that the user has provided, right? This is not new. However, this is the first time that somebody from HR can do it, that a guest can do it, that anybody in the org can do it. And more than that, when these applications run, they are not telling the user, hey, here's the list of permissions we're going to use on your behalf. They're telling them, hey, give me a connection to Outlook. What do you think are the permissions behind that connection? Everything in Outlook, right? Everything in Teams, everything in everywhere else. So this specific application that I'm building right now, I just took off a random application from the marketplace. This is an application for an out of office, to facilitate out of office, so it will auto-decline calendar events for you. And so it needs access to your email. So what I'm doing here right now is just typing a single line of code that will use this connection to send an email on the person's behalf to my account saying I've been pwned. Now, of course, I could have done lots of other things, but the crucial piece here is that there's no way for the user to know what I'm actually doing with their account, because they're providing me with a connection, which essentially is an asterisk over all of the permissions for that specific application. Now, I've created this application, I'm publishing it. You'll note it's difficult to see, but if you can see the URL, what you'll spot is that this application is going to be hosted on a Microsoft domain. So again, this is creating an internal phishing campaign where all I need to do in order to get somebody's account is to get them to click on a link that is facilitated by Microsoft to log in with their own corporate account, which is something they will be used to doing because they're using these kind of applications, and then I will do whatever I want with their connection. All right, then you can see that once a user connects to it, I get the email that I've been pwned. Now, the number one thing that is the only constraint here in this entire kind of internal phishing campaign is this window. When a user uses the app, they get prompted with this window that is telling them, hey, this application is going to use these connections. Again, notice that this is not the OAuth consent flow. You're not seeing the permissions that I'm asking for. You're just seeing the services. All right, so if I get rid of this window, if this window doesn't exist, I've reached a point where in order to create an internal, where I can create an internal phishing campaign that requires the user to click a link provided by Microsoft, and that's it, okay? So this would be very bad, right? This shouldn't happen. Unfortunately, it's an option provided by the platform. So there's actually a valid reason to do this. So because business users could be used to using those applications, and then you don't want to create hurdles for them to actually do it. So some organizations are choosing to remove this consent window, which is of course very dangerous. If you're a Microsoft shop, I strongly encourage you to make sure that this flag is off. All right, so we're done with the leaving off the land stuff. The next thing I want to show you is persistency. And this is actually pretty interesting because what we're going to do is we're going to follow through footsteps of an APT group that used Power Automate, Microsoft automation feature inside of Office, to remain persistent within an organization. And basically what happened there, the name of the organization wasn't disclosed, but what happened there is that there were a few different malware families in this organization, so they knew they were breached. They were looking for more infections, and the investigative team took about 6 months to find that this automation was actually active, because of course they weren't looking inside of low code. And what is actually automation, and what happened is that the attackers, they were able to gain access to an admin's account. And then, I mean, the next logical step is typically kind of installing malware, moving laterally through the network, right? So they didn't do all of that. Instead, they created a single automation. This automation ran on a schedule, and every day it used the e-discovery feature from Office to find secrets and PII inside of the organization and just send it off to a random endpoint, to a specific exfiltration endpoint. This simple automation was there for 6 months without anybody noticing, because again, how would you notice? You don't have logs for this. You don't know this is impersonating a user, and this is also not something you would typically expect. So let's try to rebuild this on our own. Here's a very kind of rudimentary version. On a recurrence, I'm going to go to a specific SharePoint site. I'm going to loop through all of that SharePoint site. I'm going to encrypt each and every file, dump them to a random HTTP endpoint, and then tweet about it, because why not? I mean, nobody will catch me. Okay, so this is actually what the attacker did, but let's take it up kind of a few steps forward. One thing that I want to do is I want to have the capability to actually run this whenever I want. And I want this capability to be detached from the fact that I still have a user to that organization. So instead of doing this on a schedule, I can create an HTTP webhook, an HTTP endpoint that would allow you, that every time I hit that endpoint, this automation will run. And these endpoints typically use some sort of a hard-coded string as their secret. So you can connect to it from anywhere. You don't have to be authenticated. So again, this is very easy, and this is a snapshot from a different platform, specifically Workato. Okay, so you see where I'm going with this. I'm going to try and create a more sophisticated persistency mechanism. So here's a laundry list of all of the things that I would like to do. So for full persistency, I would like to have the ability to run code remotely. That's obvious. I'd like to be able to run arbitrary payloads, not just one payload like you've seen a moment ago. I'd like to be able to maintain access even if the user is revoked or deleted or whatever. Of course, avoid detection, avoid attribution, and I want to leave no logs behind. The question is, well, can I do this with low code? Okay, so this is the first version. We've already seen this. This is basically a persistency mechanism, this HTTP endpoint. Let's see what it covers and what it doesn't cover. So it does cover remote execution, right? I execute it remotely. This is a single payload, so we don't get arbitrary payloads. I can maintain access. You can see you might be able to see the URL with the hard-coded secret there that allows me to actually go to this endpoint and trigger it. Avoiding detection, this is somebody else's cloud. You don't get logs on this endpoint. I mean, unless you're very sophisticated and try to do something kind of, not out of the box anyway. Avoiding attribution is easy because you can just call this through Tor. I mean, nobody's blocking you. There's nothing protecting. There's typically nothing sophisticated protecting this endpoint. And no logs, well, not at all. These platforms can generate a whole bunch of logs for each application, for each execution of those automations. This is actually a problem in and of itself because the platforms can log actually the data that goes through these automations. So let's see if we can do something better. Here's a second attempt. So instead of having an HTTP endpoint that's going to use one payload, I've created a bunch of payloads here. You can see leak SharePoint, ransomware SharePoint, execute a SQL stored procedure somewhere, so you get the point. I can do whatever I want here with this. But again, I didn't really solve anything, not the arbitrary payloads and not the logs. So let's try and see how we can solve everything we wanted. Now, the crucial piece in order to do this would be something called something which is the management features of those local platforms. So if you have if you are trying to manage a local platform, what would be the best technology for you to do it with? Well, low code, right? So you can build low code applications to manage the local platforms themselves, which would require this whole set of this interface, which is about management of these applications. So specifically here, I'm going to use the Power Automate management connector, which allows me to create automations, delete automations, execute automations, etc. So here's a new tool I'm going to introduce to you today. What it's going to do is install a backdoor within an organization, within their Power Automate instance, if they're using Microsoft, which is kind of most organizations. And it will allow you to basically send every payload imaginable, execute it, and then leave no logs behind. Here's how it works. It has a single HTTP endpoint, which is it installs. Behind that HTTP endpoint, I'm going to, to that HTTP endpoint, I'm going to send the definition of the automation I'd like to build. So here's an automation. Just like a JSON file I need to send with all of the details about this automation. What this tool is actually going to do is it's going to create the automation, run the automation, and then delete the automation along with all of the logs of that specific automation, right? And it's going to do this one after the other. Of course, the tool also provides some convenience mechanisms for you, so we will handle errors and a whole bunch of things that you don't need to worry about it. So this is the final kind of automation that this tool will install on your target. And here's a kind of nice Python script around it because, well, hackers or red teamers, we usually prefer code to drag and drop. So you can use this, and again, this is what it does, what I just explained. It also allows you to continuously iterate through those connections, those existing connections. So if you'd like to use one of them, you can do it. Now, of course, the idea behind this kind of project is just to give you the tools so you can show inside of your organization just how risky this thing is, and try to measure whether your defenses will help you here. So this is a tool to help you calibrate your defenses and also kind of get the get the mind share that you need to invest in this space. All right, so in terms of our laundry list, remote execution, well, of course, arbitrary payloads, I can send whatever automation I'd like here. So this is everything that can be done with Power Automate, but trust me, it's a pretty powerful platform. You can maintain access, of course, this is an HTTP endpoint, avoid detection and attribution, we've talked about it, and logs, the main problem here is that once I delete the automation, the logs get deleted as well. So that leaves it at that. Okay, so we've seen how, and again, this went far and beyond what the APT group has actually did, but this was nothing sophisticated, right? Everything was kind of very basic. All right, so the last type of attacks I'd like to do, to show you today, is attacks that require nothing from the get-go, because everything I've shared up until now required some sort of initial access into an enterprise. Some account, could be a guest account, could be a low privilege account, but it requires something. Now, what can I do with no access at all? So this is the world of kind of misconfiguration. And the number one thing you can think of, which I talked about at the beginning of this talk, was the OpenS3 bucket for AWS, which we've tried to solve for many years now. So AWS has actually this year produced some capabilities that are actually helping with this. But even if the default is fine, if the default is not sharing the S3 bucket with everybody, people can still make mistakes, right? So we're going to see how this pops up again in low code. Let's start with Microsoft. Microsoft has some, as an application, a type of low-code applications called Power Portals or Power Pages. This is a low-code application that is with the intention of being available to everybody on the internet. This is simply a website. And you use this, for example, for contractors that are arriving physically to your, into your org, or people that are outside of your organization. They can register, they can view resources. Some resources in these websites are for administrators only, for example, but some of them are for everyone. And so essentially, this is a website. It has a managed SQL server behind the scenes, wrapped with an API. And so this, and one of the key features about, and this is how it looks like. It's like a very rudimentary website. One of the key features that this application, that this type of applications creates for you is an API endpoint. You can spot it here. Portal, you replace portal with your own portal name. This API endpoint is always created for your portals, and it allows you to use the basically REST API to query everything behind the application. Of course, you should need to be authenticated, right, in order to use this API. However, there are cases where you want data to be available to anonymous users. So users that just enter the website for the first time, you need them to be able to, I don't know, query images or something. So this needs to be a possibility. And so this endpoint is available to anonymous users as well. All right, about a year and a half ago, the team at UpGuard discovered that the default setting for Power Portal was for everything in the database to be available through this endpoint to anonymous users. Everything. Everything that is kind of administrative resources, everything. And this was the case for several years. By the way, I'm not sure that this is the case, but about 6 months later, Microsoft did a rebranding of Power Portals to Power Pages with a high push on security, and they actually have done some work pretty quickly to change the default here and to help customers identify misconfigurations. But still, of course, people make mistakes. So one of the things we wanted to see is how many of these mistakes can we find, and so here's our goal. We'll try to find misconfigurations, misconfigured portal that expose these endpoints. And this is a real example of a request of kind of the response that you get when you query this endpoint. You can see that this is basically a list of tables that I can query. Default has nothing interesting. Entity forms that is just where form submissions are being saved. But global variables is an interesting one, right? And this is a real example from a large financial services company in the US. Here's what you get from global variables. You get authentication tokens, bearer tokens and authentication to Azure, API credentials to Azure. And of course, this is, again, available to every organization. This was, of course, to everybody that queries the endpoint. This was, of course, disclosed and fixed. Now, the crucial, so we can see that there's a misconfiguration here. The other thing we need to see is, I mean, how do you find these things? How do you find these misconfigured portals? The problem is that it's very easy to find them because they are all in different subdomains in the same Microsoft domain. So just kind of a very basic subdomain enumeration. Because this is Microsoft, I'm going to use Bing. Here's a quick subdomain enumeration for you. You can see how many portals there are with this kind of that are hosted on this platform. So again, this is a way for there's an easy way for a hacker to iterate through all of those different portals and to scan them for this misconfiguration. It's very rudimentary. And when we did something like that, in order to find all of the different vulnerable applications and then disclose them to the vendors, we found a whole bunch of information. You can see some of the types of the data we found here, but there's more information in this link. Of course, we reached out to everybody that was infected. Okay. Let me show you one other example. So here's an example with Zapier. Zapier has this, Zapier runs automations, but these automations are stateless in nature, so you don't have any state that you can maintain. If you want state, if you need state inside of your automation, there's a service they have called Storage by Zapier. It's basically a key value storage, okay? But the problem is that the secret behind it is a GUID that's kind of, according to the documentation, it's a GUID. It's a GUID that, well, the key that you need to provide for this storage is a random GUID. However, when we looked at the actual docs of the API, what you'll see here is that in the examples, there are secrets that are definitely not GUIDs. Right? They are definitely not random. They are definitely not strong enough. And so we figured that, well, what the heck, let's try. Let's try and see whether we can find keys that are not these random GUIDs. And bear in mind, the only thing you need to do in order to query this API, again, is to have that key. You don't need to be authenticated. Okay, so let's just try, for example, 1, 2, 3, 4, 5. We tried it, and of course, it worked. So what we had there is, so you can see, I have examples, so I'll show them. Here's the message where the secret is incorrect. So you get the secret must be a valid UUID 4, okay? Here's the message when it's correct, just a bunch of data. So we got a bunch of information there, again, authentication tokens, API keys, emails. We simply used an enumeration attack, right? We just went through lists of common passwords and iterated through them. And actually, when we went to Zapier with this and talked to them about it, what actually happened was that they initially didn't have any verification of the that the secret is actually a UUID 4. Instead, they just told the user, hey, I mean, it's your responsibility, right? Please enter a secret, please enter a good password. And so people used 1, 2, 3, 4, 5, like the docs say, or they used password, or whatever they used. And so this was the case for several years until someone found it. They told Zapier about it, and Zapier's solution was to deal with every new secret out there. So today, if you use this platform, this feature, you have to use UUID 4. Well, but what about old passwords? These are still there. And by the way, they are still there today. So in some cases, people have stopped using them, but this is kind of just a cleanup that is difficult to actually accomplish, and so this is still an active problem. All right. Here's a summary of what we've seen so far, and I have just one other thing to share with you today. And so we've seen that low code is a big thing, and it's a big thing in every organization. And I strongly encourage you, don't go into the place where you think it might not be your problem, because you'll end up exactly where we ended up with bring your own devices, solving it a few years too late. It's vastly underrated by security teams, and we actually don't have the right tools in our tool set to deal with this, because we don't have the monitoring capabilities. There's no SDLC. There's no way to do this manually. Business users are not security savvy, nor should they. There's a huge challenge for us to address here, and we need to be proactive about it. Attackers are already taking advantage of this. We've seen a bunch of examples of leaving of the land attacks because these platforms operate as credential sharing as a service. They are basically the perfect place for a hacker to be at, and the permissions you need in order to gain access to these types of platforms in organizations are pretty low. You've seen hiding inside of those platforms, persistency mechanisms. Again, APTs have already used this. You've seen predictable misconfiguration. This is nothing new. We've seen this again and again with every important platform. This is just another one. And note that this is always about the platform saying that the choices are up to the user. That the platform has created a secure platform, but the user has to choose a good password. The user has to to choose the right permissions for their APIs. Of course, when it's easy to make mistakes, we make mistakes. You've seen a couple of tools that I've shared here today. One is Zapcreds that allows you to identify these overshared credentials in Zapier. The other one is installing the backdoor in Microsoft 365 that you can play around with. I also encourage you, if you're interested, check out the Google for no-code malware. You'll find a tool that allows you to use RPA basically as a malware for Windows 11. And now the last thing I'm going to finish with is actually defense. So what is the best way for us to approach it? So how do we move forward? The number one, so there are a bunch of recommendations here, but let me kind of narrow it down for you. One thing that is pretty obvious is that if you don't know what you need to protect, you won't be able to protect it. So I know it's a it's a difficult thing to say, but we need to inventory those applications. We need to know who builds them. We need to be able to have logs. When something happens, we need to be able to actually investigate it, right? This requires work. We need to work with the teams that are building those platforms, managing those platforms, search for them within your organizations, you'll find them. We need to be part of the conversation for low code. And one other thing to say about that is that these people, at least the people that are managing those platforms, they are aware of the risks and they're afraid. They're afraid because they're alone and they don't have the security teams with them to guide them in that process. So be there to help them build it in a secure way, and they will appreciate it because they will be able to use the platform more robustly. Review those configurations inside of those platforms. These platforms are creating HTTP endpoint on your behalf. They are exposing business data. You need to be able to control this. There are two specific configurations that I've shared in this talk that I strongly encourage you to look at. One is about connector usage, just and those open endpoint, OData and storage. And the other is the bypass consent flow for Microsoft. Check out this one; it's really important. The number one resource that would help you if you want to be the champion of low-code security within your organization is the OWASP Top 10. This is a project that is dedicated to low-code, no-code apps and the types of problems that happen when business users are building those apps. This is different from the traditional OWASP Top 10. It's focused on business logic, what these applications are actually doing, and it will give you concrete examples that were found across the industry of problems that were found, and also a language you can share with your business users and with your leaders to push this forward. That's everything I had. Thank you very much. Yes. Yeah.
You mentioned that when you delete that automation flow, it deletes the logs. So there's no location where those logs would be stored after the fact. There's no permanent location for those, or a way to retrieve those after the fact?
You can route those logs to a storage account that is separate, and then if the automation gets deleted, the logs won't get deleted, but it requires an action from your side, an administrative action. It doesn't come with the vanilla configuration. Yes? Only if you use a connector that is underlying under the surface using the Graph API, and then the new Graph API logging capabilities might help you. But no, all of the Power Platform API that are being used here, they are not logged. Again, not by default. Yes. Again, not by default. if you want this to be part of your own kind of configuration of your, if you want your SOC to be able to monitor this, you need to be active, to be proactive.